In this demo, we'll be going over basic closures. A closure is simply an anonymous function that you can create within your code. To get started, we have an add function, and it just takes an a and a b value and returns an i32, and the body adds the values together. In our main function, we are calling the add function, passing in a 1 and a 1, and that will return a 2. I'll be creating a closure that implements the same functionality as our add function. Now, closures are anonymous. That means they don't have names. So to create a closure, we're not going to need a name for a function. And since it's not a function, we're not going to be using this fn keyword either. I'll be renaming our existing function. That way we don't get it confused with our closure that we're making. Since closures are anonymous, we're not able to define them here like we would a function. Closures must always be defined within another function. It's also possible to give them a name, but it's not required. In this case, I'm going to give it a name by using the let keyword, similar to making a variable. I'll be naming our closure add. So we type in let add equals, and then to create the closure, we use vertical bars or pipes. So these are called pipes, and these correspond to the function parameters when we create functions. So instead of using the parentheses as we do here, we use pipes, and we'll put the arguments between the pipes instead. And just like functions, we can return a value. As you can see, it looks almost identical to the add function. We have our a and our b. The comma is still there. We have our types set. We have the arrow to return, which returning an i32. We have curly braces for the body. And finally, the body of the closure is identical to our add function. If we wanted to use this closure, it would be the same as using the function. So we can call this closure just by typing in the name of the closure, because we gave it a name, and passing in two values that are appropriate for the closure arguments. Now at this point, you're probably thinking, why would I create a closure that I can't give a name when it's basically the same length as this function? We still have to specify the types and the return values and all that. Well, technically, you don't have to specify all of this. So I'm going to write this in a way that you would normally write it without having all the type annotations. We'll give it the same name, and here are the closure arguments. And then we're just going to supply the body of the closure, and we're done. Now we have a closure named add. It accepts as its arguments an a value and a b value, and it returns the value of a plus b, just like the function and just like this closure here. So these two closures are identical. The reason we don't need to specify the i32 here and here, and we don't need a return value, is because when we call this closure, we're supplying two numbers. So Rust is able to figure out that this is a number and this is a number. We also know by default that Rust will automatically return from function bodies when you perform an operation such as a plus b, which we're doing here. So it knows it's going to return a value as well. And it's able to infer all the types required. So we don't need this, we don't need that, and we don't need the return value, and we don't need the curly braces. So this is all that's needed to define a closure. In addition to just being much shorter than writing a function, it's also convenient when you need to pass in a function as a function parameter. So it is possible to create a function similar to the add function, and that function will also accept another function, and then it could run that. So you can write functions within functions, and you can write functions that accept other functions and run those functions. I know that was a mouthful, but once we get to function combinators, we'll see that this shorthand closure is extremely convenient for making your code easier to read and work with. Closures do offer additional functionality, but that will be covered in a later video on advanced closure usage. This concludes the demo on basic closures. I'll see you in the next presentation.